what we study in chemical kinetics and why do we study chemical kinetics. Okay, so chemical kinetics is basically the branch of chemistry, right, which deals with the study of rates, right? We, in the chemical kinetics, we study the study of the rates of reaction, means how fast or how slow the chemical reaction is. Okay, so basically,
Yes, ma'am.
what is yeah, so chemical kinetics, we study the rate of chemical reaction. Okay, and basically we can say that uh, in how fast chemical reaction proceed from the reactant to product, because we know that in a chemical reaction the reactants just proceed, it just convert from reactant to product. The reactants just react with each other and they proceed to the product. So basically in this chemical kinetics we just get to know how fast chemical reaction proceed and how fast the reactants convert into the product. Got it?
Yes, ma'am.
Okay. And basically the factors which affect the chemical reaction or the rate of chemical reaction and its mechanism. So we will study in this chapter. Okay. So we will see each and everything and we will get to know what are chemical kinetics, and basically this is very important chapter. Okay. So just please focus here. Okay. First, and yeah, one more thing I want to ask you, what is the scope and importance of chemical kinetics? Do you know why we
No,
study
I'm not
chemical
sure.
kinetics?
Is it just to like understand the rate of reaction? That's it.
Yeah, basically it helps us to find the conditions to maximize the yield of the product. Okay, basically to maximize the yield of the product, जो हमें product चाहिए वो maximum हमें मिले. Okay, कहीं पे waste ना हो. That's why we just study the chemical kinetics and we just uh, get to know how the chemical reaction proceed and how fast the chemical reaction is. Okay, so you can also add this. You can write here. So in chemical kinetics, we study the rate of chemical reaction, right? And along with the course of all physical and chemical processes, all the physical and chemical processes which are induced during the reaction. Okay, so basically, this helps us understanding or finding the conditions. What should be the conditions of the chemical reaction that we can maximize the yield of the product? We could get maximum yield of the product. Got it?
Yes, ma'am.
Okay, let's
So
write down.
that's why we use chemical kinetics.
Yeah, yeah.
Okay.
First, let's write down the definition part. So, chemical kinetics.
Also, ma'am, will you be providing these notes?
Yeah, yeah. You
Okay.
have to write down the notes along with me. Yeah, just
Yeah,
make
I'll
notes
write
along
it
with me.
down too.
Yeah, yeah,
Okay.
just. So, chemical kinetics is the branch of chemistry. And please, after every class, just revise these notes. Okay, and try to solve the questions from the NCRT. Okay,
Okay.
Riddhi?
Yes, ma'am.
It's a branch of chemistry which deals with, just a second.
Ma'am, you can dictate it to me if you want.
Just a second. I don't know why it's hanging too much. My laptop.
Okay.
No, no problem. I'm dictating it. So write down. Chemical kinetics is a branch of chemistry which deals with the study of rates, which deals with the study of rates of chemical reactions.
Yes, ma'am.
Okay, next, write down scope and importance of kinetics of reaction. Scopes and importance
As
of,
a heading.
yeah, another heading. Scopes and scope and importance of kinetics of reaction. Done?
Yes, ma'am.
Okay, okay, write down. In kinetics, we study the rate of chemical reaction along with the course of, in
We,
kinetics,
yeah,
we study the rate of chemical reaction along with, along with the course of all physical, along with the course of all physical and
the
chemical
course.
of
Okay.
all physical and all physical and chemical processes, physical and chemical processes induced during the reaction, induced during the reaction.
Yes, ma'am.
Okay, so this helps in finding the conditions. This helps in finding the conditions
Conditions.
to maximize
This helps in
max,
finding the conditions and to maximize.
to maximize the yield of the products. To maximize the yield of the products. Yield means your quantity of the product. So that we get the more quantity of the product.
Yes,
Clear?
ma'am, done.
Okay, next heading, classification of reactions on the basis of rate of reaction. Classification of reactions on the basis of rate of reactions.
Yes, ma'am.
Okay. First, let's understand what is rate of reaction. Okay, so basically, rate of any reaction is the change in concentration. Just a second. Let me check ये काम कर रहा है कि नहीं? Yeah. Okay, so first let's understand what is rate of reaction. Yeah. So rate of reaction is basically a change in concentration with respect to time, right? So rate means the change in concentration of reactant or any product with respect to time. That is your rate of reaction. Okay. So rate of
Okay.
reaction, yeah, is the change in concentration of reactants or products per unit time or with respect to time. Okay, and for example, for a general reaction, for example, A plus B, they react to form C, right? So what is A here? So A and B are the reactants. These are the reactants. They react together and they form a product, right, which is C. This is your product. Okay, so let's see how to write down the rate of reaction. So rate of reaction, basically the rate of this reaction will be, yeah, the change in concentration. And change को हम किससे show करते हैं? So it's delta, right? So delta concentration of A upon your T, delta T.
Wait, could you repeat why we're writing delta A?
Delta means your change in what is the rate of reaction. We just said that, I just said that rate of reaction is a change in concentration. And change को हम किससे show करते हैं? It's delta. Delta is the change, right? Change in concentration of reactant. Reactant for A, what could be the rate of reaction? So it's minus delta A, concentration of A upon delta T. Right, and why
Okay.
negative sign here? So the negative sign, this indicates that the concentration is decreasing with time, right? Because they are being consumed, right? The A plus B, the reactant A and B, they are consumed in the reaction and they just convert it into the product, right? So its key
Yeah.
concentration क्या हो रही है? So it's decreasing. The concentration of reactant is decreasing. So that's why we just put negative sign in the rate of reaction for the reactant, right? For
Okay.
the reactant, we always just put here the negative sign. The negative sign indicates that the concentration is decreasing with respect to time. Got it?
Okay. Yes, ma'am.
Okay. If I have to write down the rate of reaction of B, B reactant. So how I will write, so delta minus delta, because again it's a reactant, right? So minus delta concentration of B upon your for this product. How we can write down for product? So for product, we don't use minus sign, right? Because it's the rate of formation, right? Because this is the, we can also call it as the rate of consumption of reactant because they are being consumed in the reaction, right? And after being consumed, they just convert it into they just form a product which is C, right? So we use the rate of formation for the product, rate of formation for the product, and rate of consumption, rate of consumption for the reactant. Okay, so the rate of formation or the rate of reaction of product will be your delta C upon, so sorry, concentration of C upon delta T. Okay, in the positive way, right? Because it is not being consumed, इसका concentration increase हो रहा है ना कि decrease हो रहा है, right? So it's positive sign here, right? For the product we use positive sign, and for the reactants we use negative sign. Got it, Riddhi?
Yes, ma'am. Can I just write this 1 second?
Yeah, just write it down.
Done, ma'am.
Now let's talk about the unit of rate of reaction. So the unit of rate of reaction is, you can see over here, this is concentration, right? So concentration, so it's, we can write mole per liter for the concentration, and for time it's per second, right? So the
Okay.
unit of rate of reaction is mole per liter per second.
Yes, ma'am. Done.
Okay, now let's talk about the classification of reaction on the basis of rate of reaction. Yeah. So basically, the rate of, on the basis of rate of reaction, the chemical reactions are classified in three types. Okay, first type is very fast reaction. Okay, so basically, very fast reaction is that reaction which involves the ions, which involves the ion formation, right, and which proceed so rapidly that they may be practically considered instantaneous, very fast, instant हो जाता है ये, right? इतना ज़्यादा fast होता है, बिल्कुल instant. When you add the reactant and quickly, at the instant of time, you get the product. So that's a very fast reaction. Okay, because its rate is very fast. Okay, so rate of reaction, first type is very fast reaction, and you can also call it as an instantaneous reaction. Why? Because
Uh,
this type of reaction proceeds so quickly, right? Practically, it is considered as instantaneous because you got the product very instant, in a very instant of time. Okay, so that's a very
okay.
fast reaction. For example, neutralization of a strong acid and a strong base. Okay, if you have done some practical in your lab, right? So when you must be find that when you add a strong base into the strong acid, okay, so in an instant of time the reaction proceed. वहाँ पे neutralization हो जाता है reaction का, strong acid and a strong base when they meet they just form salt, right? So वहाँ पे neutralization reaction is your very fast type of reaction because its rate of reaction is very fast. Got it?
Yes, ma'am.
Second type, very fast type, a very slow type of reaction. Very slow type of reaction. So the reaction which proceed very slowly, right? And it may take even several months or several years also, right? So that's a very slow type of reaction because its rate of reaction is very, very slow. For example, you have witnessed this, the rusting of iron, right? So the rusting of iron is a very slow type of reaction. Okay.
Yes, ma'am.
Third type, slow or moderate reaction. Slow or moderate reaction. So basically, the reaction that are neither very fast nor very slow, they are considered as a moderate type of reaction. Okay, or you can also call it as a slow, not very slow, but it's a slow type of reaction. ओके, फॉर एग्जाम्पल हाइड्रोलिसिस ऑफ एस्टर. एस्टर का जब हाइड्रोलिसिस होता है तो दैट इज योर मॉडरेट टाइप ऑफ reaction. Okay, so now
Okay.
you can write down, so these are the three types of reaction based on the rate of reaction.
So for very slow reaction, there's nothing specific like it involves ions and all, right? It's just a
Yes.
general
Yeah,
reaction.
yeah, yeah.
Okay. Ma'am, could you scroll? Yes, ma'am. Done.
Okay. Okay, so as we have discussed, what is rate of reaction? So rate of reaction or rate of any chemical reaction, it may be defined as the change in concentration of any of the reactant or product per unit time. Okay, so just remember what is rate of reaction. Okay, and what is the unit of rate of reaction? So it could be mole per liter per second or atm per second. Okay, atmospheric pressure per second. And this atmospheric atm per second is used when the reactant and products both are in gaseous state. Okay, so just remember this unit we will use when the reactant and product both are in gaseous phase.
Okay.
Okay, next is
Wait,
your average.
scroll up.
Yeah, yeah. First try to understand and after that I will give you time to write down.
Okay.
Next is your average rate of reaction. Yeah. So basically what is average rate of reaction? So average when you take the change in concentration of any of the reactant or product per unit time over a specified interval of time, it is known as rate of reaction, right? And this is, for example, A plus 2B, right? So A and 2B, they are the reactants, right? And they react to produce this 3C, right? And this you can see this is the coefficient of C, and this is the coefficient of B, and this one is the coefficient of A. Now let's say how to write down the rate of reaction if there are coefficient over here in the chemical reaction, right? So in the, for example, uh, just- for example, if it is A plus 2B, they just consume in the reaction and they will produce 3C. Suppose that. So how to write down the rate of reaction? So rate will be as I told you, in the reactant part we just use negative sign, right? So it's delta concentration of A upon your delta T. Yeah, that's the concentration, that's the rate of this reactant. Now, if I want to write down the rate of the second one, right? So it's 2B over here, right? So coefficient part, we just take it in the denominator, right? So I will write minus 1 upon 2, right? This coefficient part, I will write in the denominator. So 1 upon 2 delta concentration of B upon delta T. Okay, so that's how I just write down. Now, rate of reaction for product or rate of formation of product, you can say rate of formation of C. So it will be plus 1 upon, it will be, this is coefficient, right? So I will write 1 upon 3 delta concentration of C upon delta T. Okay,
Yes, ma'am.
okay, write down.
Okay.
Let's see, I will give you some question. Okay, write rate of consumption, rate of formation, okay, और rate of production भी इसे कहते हैं हम. Okay, the rate of the product or rate of formation or rate of production, right? So we just use it for the rate of production, and rate of reaction for the following reaction, for the following reaction. Okay, so if I tell you the rate of consumption, it means you will write the rate of consumption of the reactant. Okay, if I tell you the rate of production, so you will write the rate of reaction of the product because this is being formed, right? This is the formation. Product का formation हो रहा है and this is being used. The reactants are being used. Okay, so the question is, for example, N2, when it reacts with 3H2, it will give you 2 moles of ammonia. Okay, now write down the rate of consumption, rate of production, and rate of reaction for the following. Yeah, so rate of reaction
Okay.
will be equals. Rate of reaction of reactant, all the reactants is equals to the product. Okay, just try to write down.
Okay. So, rate of each individual reactant is equal to the product, right?
Yeah,
Or
yeah,
the sum of both of them.
yeah. All are equal.
Okay.
And yeah, always remember for the rate of reaction, use a balanced chemical reaction so that you will write it correctly.
Okay. And in the exam, will they ask us to calculate the exact value of the rate?
Yeah, the rate of reaction of or the rate of production of is given. For example, मैं अगर N2 का दे दूँ rate of consumption and I ask you to find down the rate of production of ammonia. Okay, so this type of question have been asked in the exam. I will give you
Okay.
some question. मैं वो भी questions कराऊंगी, don't worry. After this,
So rate of consumption would be for rate will be equal to minus of delta N2
mhm, yeah,
by
I'm
delta
writing
T.
rate of consumption of N2, right? So it's minus of
Yeah.
delta N2 upon delta T. Yeah, good. It's a
And then,
concentration. Yeah,
yeah, concentration. And then the for H2
yeah, rate of consumption of H2, it will be
will be
equals to,
minus 1 by 3 delta concentration of H2
yeah,
upon delta T.
yeah, good. And what is the rate of formation or rate of production of ammonia?
Uh, it would be positive delta NH3 concentration of NH3
Yeah,
by delta T.
positive 1 upon 2, it will be.
Oh, yeah,
It
1 upon 2.
2 multiplied by this. So that's how we just write down the rate of consumption and rate of production. Now, if I ask you to write down the rate of reaction, it will be minus delta N2 upon delta T is equals to minus 1 upon 3 delta H2 upon delta T is equals to half of delta NH3 upon delta T. Right, that all the are the concentration, right? Yeah, so that's
So
how
after
you
write
just
all
write
of
down.
them.
Yeah, all of them are equals to each other. Okay,
Okay.
if for example, its concentration is given, right? Its concentration or the rate of consumption is given. Okay, so you can calculate the other. Okay, तो उसके इसको equal रख दोगे and you will get to know you can calculate the other one. For example, इसका मैं
Okay.
value दे दूँ. Okay, let's do one question based on this. Based on this, let's do some question. Okay. in a given reaction, suppose it's N2 plus 3H2, it gives 2NH3. The rate of formation of ammonia is given. Ammonia is 3.6 into 10 raised to the power minus 4 mole per liter per second. Okay, and the question is calculate first one, the rate of reaction, right? Second one, the rate of consumption of H2, rate of consumption of H2. Okay, so this type of question can come in your exam. Okay, so let's see how to do this question.
Won't it be the same thing for all of them? 3.6 into 10 to the power minus 4?
No, no, it's for ammonia. The rate of formation of ammonia is given, right? So
Okay,
if one thing is given, you can just calculate the other two. Let's see how.
okay.
So rate of production of ammonia is given, which is 3.6 into 10 raised to the power minus, right? So what will be the rate of reaction? So we know that what is rate of reaction? So it's 1 upon 2, right? So suppose let's write down the rate of reaction first for each and every 2NH3. Okay, so what will be the rate of reaction? So it's minus delta N2 upon delta T, which is equals to minus delta 1, sorry, 1 upon 3 delta minus 1 upon 3 delta H2 upon delta T, which is equals to, sorry, it's half 1 upon 2 delta NH3 upon delta. Okay, that is the rate of reaction, right? Rate
Yeah,
of reaction we can write just like this. Okay, now see, this is given, right? The ammonia, the rate of formation of ammonia is given, and they have asked the rate of reaction, right? So rate of reaction will be 1 upon 2. This rate of reaction is equals to this, which is equals to this, and which is equals to this, right? So can we
yeah,
write the rate of reaction is equals to half into, this is your half, right? 1 upon 2 into the rate of production of ammonia. This is what? This is the rate of production of ammonia, right? And the rate of production of ammonia is given in the question, right? So it's
okay.
3.6 into 10 raised to the power minus 4, right? Now you can calculate this. Yeah, 2 ones are 2 and 2 eights are 16. So it will give you 1 upon 1.8 into 10 raised to the power minus 4 mole per liter per second. Okay, so rate of reaction we have calculated. Second one, they have also asked the rate of consumption of H2. Okay, rate of consumption of, so rate of, we know that the rate of reaction is equals to rate of consumption of N2, which is equals to the rate of consumption of H2, right? You
Yeah,
can write down rate of reaction is equals to rate of consumption of N2, which is equals to rate of consumption of H2 upon 3, right? So that's a 3, which is equals to the rate of production of ammonia upon 2, 1 upon 2, right? According to the balanced chemical equation. Now you can see over here, हमें क्या find करना है? This, right? And this is given, right? So we can compare this. This is equals to this, so we can calculate. Or you can also calculate it using this. Rate of reaction is given, so you can,
yeah,
yeah, so it will be 3 multiplied by this. So the rate of consumption of H2 is equals to, upon 3 is equals to rate of reaction, right? Or you can also calculate it using these two, right? Because one is known and one is unknown. We have to calculate this. So rate of consumption of H2 upon 3, this will be equals to the rate of production of ammonia upon 2, right? We have to
yeah,
calculate this, and this is given. So can
But
we write
we
down?
don't need to do that, right?
Yeah, you can calculate it using this too, or you can just put the rate of reaction, which is 1.8, which we have calculated in the first part. Okay, so 1.8,
So
yeah,
can we
in
not
both,
say that
yes.
can we not say that the rate of consumption of N2 is equal to rate of production of ammonia upon 2, which we calculated before? So it will be equal to 1.8.
Rate of N2 is not given, bache. Rate of N2 we don't
So
know.
from that, can we not find it from
Yeah,
the rate of production
yeah,
of
yeah,
NH3?
we can find out, but in the question we have to find out the rate of consumption of H2 only, not N2. Okay.
Okay, yeah.
Yeah, so from
Okay.
here you can just compare these two, because one is known, the rate of production of ammonia is known, and we have to calculate the rate of consumption of H2, which is unknown. Right, so we can compare these
Okay.
two, and from here these three will go here, 3 upon 2 into the rate of production of ammonia. Right, and we know the what is the rate of consumption. So rate of consumption is given in the question, which is 3.6 into 10 raised to the power minus 4. Yeah. So it's 2 ones are 2, 2 eights are. So it will give you 5.4 into 10 raised to the power minus 4 mole per liter per second. Right. So this is the first method. You can say that it is the first method. And you can also calculate the rate of same rate using this method too. Because in the first part, you can see over here, we have calculated the rate of reaction. Rate of reaction is 1 upon 1.8 into 10 raised to the power minus 4. Right? And we know that the rate
Yeah.
of reaction is equals to the rate of N2, which is equals to the rate of H2. Right? So we can compare these two also. We can write the rate of consumption of H2 upon 3 is equals to the rate of reaction. Okay, we can use this
Yeah.
method too. In both the case, you just got the same answer, right? So in this case, the rate of consumption of H2 is equals to 3 into rate of reaction, right? So from here, rate of
Yeah.
reaction we have calculated, and it's 1.8 into 10 raised to the power minus 4, right? So you will get the same answer.
Okay.
Okay, so from both the method, you can solve the question. Okay,
Can
so
you
this time,
scroll up?
yeah, yeah, sure. Now you can write down.
Okay, mom, can you scroll down?
And yeah, just remember the rate of consumption is also known as rate of disappearance. Okay, so somewhere if you find the rate of disappearance, so don't be confused. It's the rate of consumption, right?
So rate of disappearance.
Yeah, rate of disappearance भी हम कहते हैं rate of consumption, right? Because it's
Okay.
being consumed, right? It's consumed. So because ये consume हो रहा है, तो its concentration is decreasing, and this concentration is decreasing means it is being disappeared from the reaction, right? Disappear हो रहा है तभी तो ये product का formation कर रहा है. Okay, so that's why we call it as a rate of disappearance, or we call the rate of production the rate of formation as the rate of appearance. Okay,
Okay.
so yeah, you can write down. अगर आपको याद नहीं रहता है, so you can write down. So the rate of, it's for the react. We use rate of consumption or the rate of disappearance, and for the product we use the rate of formation or rate of production, we can say. All are the same words. The meaning is same. And rate of appearance. Rate of appearance. Okay. So you can write down.
Okay, ma'am.
And
Yes, ma'am.
okay, the solution part you have done, written.
Yeah, I have.
Okay, okay. Okay, so I'm just giving you one question. Just do that.
Okay.
For a given reaction, A plus 3B, it gives you 2C. The rate of formation of C is 2.5 into 10 raised to the power minus 4 mole per liter per second. Right? So calculate the following. First, rate of reaction. Second, rate of consumption of B. Third, rate of consumption of A. Okay, do that.
Okay. I got the answers.
Mhm. Rate of
Sorry.
reaction. Rate of reaction is? Tell me the
I
answer.
got it as 1.25 into 10 to the power minus 4.
Good. Yeah. And in the exam, please don't forget to write down the unit.
Mole.
Mole
Yeah,
per
I
liter
wrote
per
that.
second. Yeah. The rate of consumption of B.
I got it as minus 3.75 into 10 to the power minus 4 mole per liter per second.
Okay. Good. 3.75 into 10 raised to the power minus 4 mole per liter
But
per second.
you don't write minus?
Yeah, minus is the symbol which shows that the concentration is decreasing. So in the your answer, it's already known that it's a rate of consumption of B, right? So it's being consumed. So I we know that it's normal. So negative sign to I guide, right? So no need to write on the minus sign.
Okay. And then for delta A, I got it as the same as rate of reaction, that is 1.25 into 10 to the power minus 4 mole per liter per second.
Okay, good. Okay, so that's you understand how to calculate this type of question. Yeah,
Yes,
it's very
ma'am.
easy. Okay,
Yeah.
okay, good. Okay, so we were at the rate of reaction. Yeah. So instantaneous rate of reaction, as we have discussed. So instantaneous rate of reaction means the rate of change of concentration of any of the reactant or product at a particular instant of time, right? Means the change in time with respect to the final minus initial time is very, very less. Means it tends to zero, right? Means instant होता है reaction. So that's the instantaneous rate of reaction, right? And the
Yeah.
instantaneous rate of reaction, we just write it down, the R instantaneous, which is equals to minus D concentration of R upon dt, right? So here you can see the dr, this is a change in the concentration of reactant, right? And here the negative sign, you know why it is negative sign? Because the concentration is decreasing, right? So concentration is
Yeah.
decreasing means when you write the initial and final concentration, so concentration, if I say that the C is the concentration,
So
C is the,
it's the same as the rate of reaction we saw before, right?
yeah, yeah. The rate of reaction is same, but instantaneous what is for this change. The time change is
Okay.
very, very less, right? So dt means the time change here is very less because it just tends to zero, right? So instant हो जाता है reaction. So the change with the t final minus t final minus t initial it just tends to zero, right? There is no change, means zero के बराबर change होता है, right? So that's why we just write dt. The change with respect
Okay.
to time is very, very less, right? Because the reaction occurs at an instant of time, right? So that's why that's the instantaneous rate of reaction. And we just write the instantaneous rate of reaction just like the same rate. Okay, so it's minus D concentration of R, right? This is the reactant and this is the product. Right. So if I say the concentration final is there and the concentration initial concentration is there, right? So always initial concentration is greater than the final one for the reactant, right? So this is for the reactant because I just told you because the reactants are being consumed in the, this is the reactant, sorry. Yeah. Because the reactants are being consumed in the reaction. Because it's consumed, so the concentration is decreasing, right? So that's why the
Okay.
initial concentration is always greater than the final one. Okay, just write it
Okay.
down. Write it down. Instantaneous rate. Yeah, there is a, yeah, the average rate of reaction and the instantaneous rate of reaction. Time sometimes in exams they ask you to differentiate between the average rate of reaction and instantaneous rate of reaction, right? So basically, average rate is measures the rate of change of concentration with respect to time and with respect to longer time interval. एवरेज रेट हम कब बोलते हैं जब लॉन्गर टाइम इंटरवल होता है बट इंस्टेंटेनियस रेट it is the rate of change of concentration with respect to very instant time, right? So that's the difference, that's
Okay.
the basic difference. Average time क्या होता है, so it's for a period of time, longer time
So
interval.
over a
Yeah,
long period of time is average, and then for
yeah,
instantaneous, it is at a particular time
yeah, yeah,
instance.
yeah, yeah, yeah. So if you
Okay.
want to write down the difference, so I will dictate you.
Yeah, I think it's self-explanatory.
First,
This one.
if in the exams they ask you to write down the differentiate between instantaneous and average, first always try to write down the definition. Okay, and after that give some reaction example, and according to that just write down the rate of reaction. Okay, I
Okay.
will just tell you how to write down. Okay, write down differentiate. Here I'm writing the instantaneous rate, and here the average rate of reaction. Okay, so first point is always the definition. Okay, so what is instantaneous? So it is defined as rate of change, rate of change in concentration of any one of the reactant or reactant or product at a particular time, at a particular time, right? But the average rate is for a longer interval of time. It is defined as the rate of reaction measured over a long time interval. Long time interval. Okay, so that's a major difference. Suppose, let's take an example. If let us consider a reaction. If A plus B, right, it gives you C. Okay, so for the instantaneous rate of the above reaction would be, so the rate of reaction will be rate of reaction will be minus D concentration of A upon dt, which is equals to minus D concentration of B upon dt, which is equals to this. Yeah. And for this, again, let's suppose the same. Let us consider the same reaction. So the rate of reaction will be, right. So I will write down the delta, right? The rate of reaction will be your minus delta concentration of A upon delta T. Right. So delta here it shows the longer time interval. Delta T is the time taken and it's the longer time interval means initial final minus initial time. Right. So the change in
Yeah.
concentration in a with respect to time. Again minus delta B upon delta T, which is equals to delta concentration of C upon delta. Okay, so that's how you will explain or you will differentiate these two terms.
Okay.
Okay?
Yes, ma'am.
Okay, so the next is your the factors that affect the rate of reaction. Okay, so that's very important. So let's see what are the factors which affects the rate of reaction. The first
Ma'am,
factor is your yes.
ma'am, is the class over? I have another class.
No, I think the time was till 8:30.
2 hours?
Uh, yeah, no, 1.5 hours. The class starts from 7, right? So 7 to 8:30.
Ma'am,
So you have another class, Riddhi?
I think so. I'll just check and come. 1 second, ma'am.
Because मुझे जो दिया गया है तो टाइम टेबल में so accordingly I am just telling you.
Okay, I'll just go check and come.
Okay, okay, sure.
Yes, ma'am.
Do you have another class, Riddhi?
No, ma'am, I'll do that class later. I'll finish this class.
Okay, okay.
Yes, ma'am.
Yeah, so nature of reactants. Yeah. So the factors which affects the rate of reaction. First factor is the nature of reaction. Right? So basically, the reactions which involves polar and ionic substances, right? So that type of reactants, the in the reaction in which polar and ionic type of substances are there, right? So they just show fast type of reaction, right? So just remember if the reactants we use in the reaction is polar or ionic type of substances, so due to that the reaction will be very fast because we have seen the classification, right? So very fast type of reaction that occurs in the ion ionic type of reactants, right? Very fast reaction में हमने क्या देखा था? That type of reaction which involves the ions, right? So the nature
Yeah.
of reactants, nature of if the polar and ionic substances are your reactants, then there will be a quite fast reaction, right? बहुत ही fast reaction होगा and they are classified on the in the very fast type of reaction in which the polar and ionic reagents are there, reactants are there. And if the covalent compounds are there, Okay, अगर reagent आपका covalent compounds है, right? If they are, suppose they are non-metals type, right? So they, in this type, the rate of reaction is much slower. Okay, so just remember these two. If the nature of reactant is polar and ionic type, so very fast reaction. And if the nature of reactant is covalent, right? If the compound
Yeah.
you just take as a reactant is covalent type, so there may be a chance they show the very slow reaction. They will react in the reaction very slowly, and you will get the product very slowly. Right, so here the rate of reaction will be very slow in these two cases. Okay,
Okay. What does polar mean?
polar means suppose it's water, right?
Yeah.
Polar belongs to the polar bond, right? In which you can see the poor van der Waals force. Poor. Do you know what is van der Waals force?
Yeah.
What is that?
Van der Waals force, it's the attraction between the radii because of the atoms, no, because of the nucleus,
Okay, okay.
something
So
like that.
basically, yeah. So basically, polar in the chemistry, you can say polarity, which refers to the uneven distribution of electrical charge, right? If there is a molecule and you can see the uneven distribution of charge or chemical bond, right? So these are basically known as polar type of compounds, right? So basically, when you say the polar molecules, so polar molecules have permanent dipole moment. Okay, and you know what is dipole moment?
Yeah.
Yeah, so basically the polar means a permanent dipole moment. And basically your polar, if I say, so it's water. Example, right? Hydrogen fluoride, it's again a polar compound. Ammonia, NH3, right? Again a polar compound. So in these compounds, you can see the permanent dipole moment. Why? Due to unequal sharing of electron, right?
Oh,
Because in these type of polar molecules are those type of molecules because in which you can see the unequal sharing of electron, right? So that's a polar
okay.
type. Examples are water, your HF, ammonia, etc. Okay,
Okay.
and covalent compound you know very well, right?
Yeah.
Next is your concentration of reactants. So basically, the rate of reaction increases on increasing the concentration of reactants, right? Due to increase in molecular collision. When you increase the concentration of any reactants, what happens? The in between the molecules, the collision increase, right? The molecules can collide more fastly, right? तो उनके बीच molecules के बीच का collision वो increase हो जाता है due to the increase in concentration. So that's why when you increase the concentration of any reactants, the rate of reaction increases. Right? So basically, you can remember from here, the rate of reaction is directly proportional to the concentration term. Okay?
Okay.
Third one, just a second.
This one. Ma'am, could you repeat the point about the collisions?
Yeah, I said that what happened when you increase the concentration of any reactants, the between the molecules, between the reactants, the collision increases, right? The molecules collide more fastly, right? तो वहां पे उन दोनों के बीच में collision increase हो जाता है. That's why the rate of reaction increases. The rate of reaction become fast when you increase the concentration, right?
Okay. Yes, ma'am.
Okay. Now the next is there. Is my screen visible, Riddhi?
Yeah, it's visible.
Okay, next is your temperature, right? So usually, the rate of reaction, basically it increases with the increase in temperature. When you increase the temperature, what happens? The rate of reaction increases because molecules के बीच में effective collision. Again, I will use the word effective collision. It will increase. When you increase the temperature, what happens? The molecules or the particles which is present in the molecules, they move very fast, right? Due to the fast movement, effective collision increases. And due to the effective collision increases, so the rate of reaction also increases, right? So
Okay.
basically, the
So it's
temperature,
directly proportional.
yeah, is directly proportional to the rate of reaction, right? So the temperature is, you can write here, the temperature rate of reaction is directly proportional to temperature. When you increase the temperature, the rate of reaction increases. Okay, so for most of the homogeneous reaction, if the reaction is homogeneous type, so the rate becomes doubled, right? So rate क्या हो जाता है? Double हो जाता है for every 10-degree rise in temperature. If you rise the temperature, so every 10-degree rise in temperature, the rate of reaction becomes double. Okay, and here the temperature coefficient is given by the rate constant at T temperature at that particular temperature plus 10 degrees Celsius divided by the rate constant at that temperature at T degree Celsius. Okay, ये समझ आया? Clear?
Um,
Okay, again I'm repeating what I said.
okay.
For a, if the reaction is homogeneous type, means the reactants are homo, same type, type of
Yeah.
reactants are there, right? Homogeneous means same, right? Same mixtures are
Yeah.
there. So that type of reaction, in that type of reaction, the rate becomes doubled. Rate क्या हो जाता है? Double हो जाता है. If you increase temperature, so for every 10-degree rise in temperature, हर 10 degree temperature जो rise होगा, so for every 10-degree rise in temperature, the rate becomes double, right? And the
Okay.
temperature coefficient, when you use the temperature coefficient, so it will equals to the rate constant at that temperature. When you are, for example,
Okay.
you are talking about the 25 degrees Celsius. The rate constant at 25 degrees Celsius plus 10 degree plus 10 degrees Celsius divided by the rate constant at 3 degrees Celsius at that temperature, right?
Okay. Yeah. Okay, I'll write
Next,
it.
next is there just two more factors. If you, the presence of a catalyst, yeah, that's again very important. So the presence of a
Okay.
catalyst in a reaction also affects the rate of many reactions. Right. So basically, if a catalyst increases the rate of reaction, it means that it is a positive catalyst, right? If any catalyst increases the rate of reaction, it means that catalyst is known as positive catalyst, right? Because वो positively act कर रहा है, वो increase कर रहा है temperature को, rate of reaction को,
Yeah.
right? So that is known as positive catalyst. And if any catalyst, it slow down the rate of reaction, right? So it is known as negative catalyst, right? So basically, what
Okay.
happens when you add a positive catalyst in a reaction, what happens? The rate of reaction increases. And when you add the negative catalyst, it decreases the rate of reaction. Got it?
Okay. Yes.
Next is your, okay. And yeah, you can, if you want to write down the positive catalyst example. So, positive catalyst, for example, it's MnO2, like manganese dioxide. Basically, manganese
Okay.
dioxide is used in the decomposition of potassium chlorate. पोटेशियम क्लोरेट का जब हम डिकम्पोजिशन करवाते हैं लैब में तो we use manganese dioxide, and manganese dioxide it is basically it acts as a positive catalyst, right? Why we use in the reaction? To increase the rate of reaction, right? So you can also write example of positive catalyst as MnO, right? So MnO2 is used as a positive catalyst in some reaction to increase the rate of reaction. And yeah, sometimes iodide ions are also used, right, in the decomposition of hydrogen peroxide. Hydrogen peroxide is H2O, right? So in the lab, when you have to decompose the H2O2, right? So we use iodide ions, right? Iodide ions we use to increase the rate of reaction, right? So iodide ion basically we use as a positive catalyst, right? And catalyst का काम ही क्या होता है? To alter the rate of reaction. Either it can increase or decrease the rate of reaction, right? If it is positive catalyst, so it will always increase the rate of reaction, and if it is negative catalyst, it always decrease the rate of reaction. So got it? So for
Yeah.
the accordingly, accordingly in the chemical reaction, we use this type of catalyst. अगर हमें rate of reaction को decrease कराना है, so we will use a negative type of catalyst. And if we want to increase the rate of reaction, so we use the positive one. Got it?
Yeah.
And yeah, this positive negative catalyst is also known as inhibitors. Inhibitors.
Inhibitors.
Yeah. Yeah, because it decrease the rate of reaction. Inhibit कर देता है, right? To decrease कर देता है, that's why it is known as inhibitors. And you can write down the examples also. And sometimes alcohol is also used as a inhibitors in the oxidation of chloroform. Okay, when CaCl3 का हम oxidation जब कराते हैं, तो we just use alcohol. So alcohol just act in a reaction as an inhibitor, right? So it decrease the rate of reaction. And yeah, we also use a phosphoric acid. You can write phosphoric acid. Phosphoric acid is the negative catalyst or inhibitors. Got it?
Okay.
Yeah,
Yes,
so you
ma'am.
should know that. So what is positive and negative type of catalyst, right? So just remember, positive catalyst, it increase the rate of reaction, and negative one, it decrease the rate of. Next one, next one is your surface area, right? So basically, when you increase the surface area, obviously the rate of reaction increases, right? So
Yeah.
the rate of reaction increases with the increase in surface area of the reactant, right? So just remember this. It is directly proportional. Now you can write it.
Okay.
Yeah.
So the temperature coefficient, it's per 10 degrees Celsius, right?
Yeah, yeah,
And the in the denominator, it is also the rate constant at the particular temperature, same
yeah,
as
yeah,
in numerator, right?
yeah, same, yeah, it's same. But in the
Okay.
numerator part, you just have to add 10 degree more, right? 10 degrees Celsius more. And if it is in
Okay.
Kelvin, so just accordingly, you just have to convert it into the Celsius.
But okay. So we can't calculate it with Kelvin.
No, it's a standard. You can just convert the Kelvin in degree Celsius, no problem. And yeah, if you
Okay.
want to, yeah, if you are taking the Kelvin, so you have to take the Kelvin in both the rate constant, right? So both the
Mm.
temperature should be in the same unit, right? So at the particular temperature also, and this temperature, 10 degrees Celsius also, right? So if you are using Kelvin, so you have to convert this 10 degrees Celsius into Kelvin also. Okay, then accordingly you can add.
Okay. Could you scroll? Yes, ma'am.
And
Yes, ma'am.
okay. Is there any doubt in today's class, Riddhi?
No
Everything is
doubt.
clear? Okay, so
Yes.
I will give you homework based on this questions. So please try to do the homework and submit it as soon as possible before the next class. Okay?
Okay.
And yeah, make sure to revise the notes also.
Okay, ma'am.
Okay. Okay, bache. See you in the next class. Bye bye.
Thank you, ma'am. Bye bye.
Bye bye. Hello, Jupita. Good evening.